Now, over the last series of videos, we've been programming obviously in Python, and you've come in an enormous way. We've gone from drawing a circle to drawing a moving circle to drawing a circle that the user can control. You've explored that as far as you can. Then we started off with a raindrop, and we've had one more raindrop drop. Now, the thing with raindrops is they rarely come in ones. They're more a pack animal, if you will. If there's one raindrop, you can guarantee there's more than one. And we're going to create lots of raindrops, and we're going to do that by introducing you to a concept of classes. Now, to do so, I need to run idle. So I'm going to get idle up and running. We're going to create a new file in idle. So I'm going to go to File and then New. And I'm going to type in the code really quickly. And there's the skills of touch typing. Or I did it earlier and I just copy and pasted it. But it's up to you. I'm going to close down the window at the back, the immediate window. All I need is this file. This is the file I need. I'm going to go to File, Save As, and since this is more than just one drop, I'm going to call this Raindrops. I'm not going to overwrite my old file because that's useful. I can go back to that and look at this. This is the code we want to look at now. So I'm going to call it Raindrops and click on Save. Now my recommendation is that you pause, stop the video, whichever one you wish, and you don't stop the video, that won't work. However, pause the video and type in everything you see on the screen. When you've got it there, you want to make sure that it works. Come back, we'll run ours, and then you can see if what you get is what you're meant to get. Okay, so go off and code now. Welcome back. Or you never left. I have no idea. Anyway, let's have a look. What does this code do? I'm going to go to Run and Run Module. I could have pressed F5, by the way. It's good to get used to pressing the keys. But here we go. So what have we got? We've got a screenful of raindrops falling from the top of the screen downwards in our new window. How big is that window? Well, we're going to find out that this is 1000 pixels across by 600 pixels down. So it's just on the bottom of that green line. My mouse accuracy is quite shot, so that's 600 by 1000 across. And we've got lots and lots of raindrops. Now our old code had us creating rain underscore x and rain underscore y, and we could have created rain underscore y1 and rain underscore y2, and we could have created lots of variables for each raindrop and create a storm that way. But imagine, look at what you're looking on the screen. If we had to create a variable for each one of those raindrops, this is going on for ages. That coding would take you forever. And we don't do that in coding. What we do is we let the computer do the work for us. But to do so, we have to understand something called classes. So I'm just going to close down the immediate window. That will close down, kill the other program. And let's look at the code. Now some of this we've seen before. Let's have a look at the top line. We've got the import line. This imports the modules that we need. We know we need Pygame because that's the system that we're using to do all the drawing with. The sys allows us access to some of the system controls. Time gives us our clock. And random allows us to have random events, randomized values. That's the one we're interested in. So each one of these modules contains code that we want to have hold of, that we want to use. So Pygame has a whole load of code that we want to use. So does sys, so does time, so does random. How do I know I need to use those? You will get to know which ones you need to use, when you need to use them, because you'll be looking up on a piece of code and someone will say, oh well, to do that you'll need this module, and you'll know to put it into the import. The next part is the from, and it tells from pygame.locals import everything. So import everything from the local part of Pygame. That means we don't load the whole of Pygame, we just need the locals area from it. Everything else is perfectly fine. We then initialize Pygame. We set up what we need. This sets up the system We don't need to know what it's doing, we just need to know that for Pygame we need to run .init. We've then got our caption. We've seen this before. This uses Pygame to and the display is a window that we see similar to this window, but we know it's that big window that's going to come up, and it sets the caption to rain. So we now know that any display that Pygame is going to create, the caption is going to be called rain. And then we give this display a name, screen. We set its dimensions, 1000 pixels wide by 600 high, and we tell it to give it a name called screen. Here we're using Pygame time and creating a clock. So we're creating a clock and we're giving it a name. Remember that this is a class, we're going to be looking at those in a moment, and the clock is an instance of that class. That means one clock out of all the clocks that we can create. And then a variable that we're not going to use at the moment, raindrop underscore spawn underscore time equals 0. So we're not using that at the current moment in time. We will do later on. This is a variable, we're assigning it the value 0. Remember, equals is assigned to, assign 0 to this variable. Variables should be generally lowercase. Underscores can't have spaces, so underscores act as spaces. Sometimes you'll see people using uppercase after the lowercase just to help along. This is the part we want to explore. This is the part that we're really interested in. But we need to come back to that in a moment, so please just bear with us. This is a variable. The variable is raindrops, equals, and then two square brackets, which look rather weird. The square bracket tells us that raindrops is going to be storing what's known as a list. Now a list is, how do you explain a list? Well, the most effective way, it's like a shopping list. We can store several items in this variable, several items in the list, and it can appear in there. For example, we could put different colors in there. And so it's a list of colors. Now, ooh, that's a weird color. That's a list. That's a 3-item list. We've got 3 values in there, 3 strings. These are strings. If they've got speech marks either side, we now know that this is a string. It's worth noting that one thing within a string is called a character. Now duck3 is not a string. Sorry, it is a string, but it's not a color, but it is definitely a string. How do I know it's a string? Because it's got speech marks around it. That is a string. It's only got a number in it, but the computer won't see it as a number, it will see it as a string. Don't do any weird mathematics with that, it will get very, very complex. But that is a string. So anything in speech marks from a computer's point of view tells the computer it's a string. What other kind of lists can I do? Well, let's take the 3. There's a list. It's a list of numbers. This list of numbers will be stored in raindrops. These are integers. Integers. An integer is any whole number from 0 upwards and negatives. So there's nothing wrong with me putting 0. There's nothing wrong with me putting -4. But there's something very wrong with me putting that 0.5, because 0.5 is not an integer. An integer is any whole number, positive, negative, or 0. So there's another list. So if I put speech marks, I know it's a string. If I put a value just like that, just a whole number, positive, negative, or 0, I now know it's an integer. What other kind of list can I do? Well, let's put our fractional numbers in. There's a list. This is a list of decimals. You can also have them termed singles or even doubles. They're too big for doubles, but they are certainly singles. Or decimals. Decimals are perfectly fine, and those are any number with a fractional element. So a decimal, any value with a fractional element. But I didn't have any of that. I had this. And that says raindrops is a list. What kind of list? This is an empty list. Why is it empty? Well, because it's not got anything in it. It's like a dustbin, but with no rubbish in it, or a washing up bowl with no water in it. It's empty. It doesn't contain a list. There is no list there. There is no list. No list is there. No list. Doesn't matter how I form that sentence. There definitely is no list in there, and therefore raindrops is an empty list. We'll come back to that list shortly. It will still be empty, but then we're going to fill it up. I'm going to leave that topic. Okay, the next one, while one. Now we got used to this. The while is a loop. It will loop through any code that is indented from this point. So this is colon, and that colon says, okay, look for anything four spaces indented from this while, from this point till there's not something indented. Now all our lines are indented, so all of these lines exist within our while loop. This will run while a condition is true, so it will run all these lines of code. It will get to this line, go back and test this again, and it will say, okay, is the statement I've got still true? If it is, run this code again. It will get to the end, it will come back to that line and says, okay, is the condition I'm looking for still true? If it is, run this again, and then it will get to the end, and I think you get the point. What is the condition? The condition is here, and we're only using what's called an infinite loop. We've looked at this before. The infinite loop in this case is while one. Well, that sounds weird. Weird. But what it means is while one is one, or one is always one, therefore this will always be true. So this code will constantly run through these lines infinitely until we tell it to stop. We've got our clock, we've got a value in our clock, so it's not going to send us data, it's going to take data. It's going to limit the number of times we can run through this loop to 60 times, 60 frames per second. For event, if any events occur in pygame.event.get, then run through these for each. So this here, this could be a list again of items, a list of events that we've got, and it will take each event and it will check it, event type. Now it could be a mouse click, it could be a keyboard press, it could be anything. But if that event, that single event that is found in this list of events, if it is equivalent to, if it compares to quit, then exit the system. That's why we've got the sys.exit, exit the system. Now we know that within idle, if we try to exit the system by clicking the red X, it doesn't work. Later on we'll find different ways of running this, but this is perfectly fine at the moment. So this will exit the system. When will it stop here? When it's gone through all the lists. So if you sat there banging away on the keyboard and knocking things around and clicking the mouse button and everything else, this will run a little bit slower because it runs through all those events. Then we've got this weird line. We'll come back to that line. Let's move on. This one, we've seen this one, screen, that's our name of our display. Could have been called Deirdre, but we didn't. We called it screen. Oh, we could have called it Deirdre. Let's call it Deirdre. No, let's call it screen. Okay, we've called it screen. Let's stay with that. So we're staying with screen. Deirdre would have been nice, but we called it screen. Screen.fill. Screen.fill. Fill our screen with a colour. All the red, all the green, all the blue, which makes white. Fill our screen white. What screen? Our display that's 1000 by 600 pixels wide. There's another 4. Here's another loop. It's a different type of loop to our while loop. It's not waiting for a condition to change. It's counting through things. For raindrop in raindrops. What's this raindrops? Oh, it's this sentence, this command I've avoided here. But it's also this list. For raindrop in raindrops. Look at our list, and for each raindrop, take the first raindrop, then the second raindrop, then the third, and however many raindrops are stored in our list, take it and do these two actions here. Where do those actions come from? The class, which we've skipped. So we have to come back to that. Hold on. Raindrops. For each raindrop in raindrops, but there are no raindrops. It's empty. Aha! But we skipped a line. But let's worry about that again. Let's look at the very last line. This is pygame.display.update, and we know that that updates the display, so we then see the raindrops falling. So some of this is common. When you remember that from before, we've seen that line before. We've seen all these lines before. We've seen these lines before. Most of this is common. We're fine with that. Yeah, we've seen assigning a variable a value. Different variable name, but we're used to seeing that. What we're not used to seeing is the class, or the raindrops, the list, or the variables inside this for. So those are the things we're going to need to look at. So let's start at the beginning. This line here, raindrops, that's our list. Our list is empty. Append. Append means to add to, add on. So if I ask it to append, I mean don't delete what's in there or anything else. Add it to my list. If I append something to my shopping list, then I add it to the end of the shopping list. So this says add to the list here. Now first, when this first runs, the list is empty, so the append will attach into this list the first thing. So what's it going to give? It's going to give us one single raindrop. So what's a raindrop? Well, let's look at this class. A class defines objects. A class defines something that we can refer to. A class sets out the characteristics that matches all of these items that we want to talk about, in this case a raindrop. Now there's not much to a raindrop, it's a raindrop. But this will define what a raindrop is. And raindrops really only do one thing. They drop. They move. They move from the top of the screen to the bottom of the screen. So we've given the raindrops a property. This will define every single raindrop that our screen is going to produce. This defines every raindrop, and if we wanted to send this class out to other people, it will define the raindrops on their screen. Every single raindrop that will ever be created on our screen will be created by this class within our program. So this says go away and create a raindrop, and so this says run the class raindrop. What defines the raindrop is all in here. The def is important. It's indented, so it tells it it's part of the class. The def is define. Define something, and we follow it with a name. Def something. Def something. Now what the name that comes after def is up to you. It doesn't matter. Except for this one. Except for this first one. Def underscore init. Def is short for definition, define. Init is short for initialize. Initialize is a flash word for set up, start, configure. Notice that to get this to work you need two underscores. That's using the key next to the 0, you hold down the shift key and you press the button that is to the right of the 0 key at the top of your keyboards. Twice there, then the word init, followed by two more underscores. That defines init, the initialization. Then we give 2 brackets, and sometimes they're empty, but in this case they're not going to be. We've put the word self in. Self is what is known as a parameter. Self is a parameter that we can refer to, that we can talk about. So self is something that this routine can talk about. We can hand it something when we run it, and it will then run the code, and it will use the variable value in there. So when we call it here raindrop, all that happens is the system goes to here and it creates the raindrop. And what actually happens is that the system will define, the system will create a raindrop, will give it a name. Now we don't know what the name is, we have no idea, but let's say it calls it raindrop 1. So what would end up happening is in this list the system would put raindrop 1. So the system will create a raindrop, initialize it by giving it a random value there and this part here, but it will initialize it so we know what sets it up. If it's not got those values, it will set those things up, and it will store its name in raindrops. For raindrop in raindrops. So once it's done this line here, it creates it and adds it to the raindrops list. Sets up the background of the screen. Then it says for raindrop in raindrops. So it says take the list raindrops and get this one to equal the first one, where the first one's called raindrop 1. Raindrop dot move, and what that will say is okay, raindrop 1 move. Raindrop 1 is of the class raindrop, so it has the move statement. The move statement says okay, using that name that we've got, raindrop, self.y add 7 to, so whatever the y coordinate is, which is initially -5, add 7, so it becomes 2. And we know the y-axis is the vertical axis, and zeros at the top going up in positive values. So our raindrop will appear at 2. The next command says draw. So take our raindrop 1, and draw it. So it will draw it. There's the screen. Draws it as black. Takes its x coordinate, which is randomly selected, so somewhere in the width of that screen. We know that they will be at 2, but the line needs 2 bits of information, first point and second point. Second point, same x coordinate, add 5 to its y, so this will be 5 pixels long. How many pixels wide? 1 pixel wide. It will then update, go back to the while, check how many frames have run, check all this, and then get to this line again. And this line says create a raindrop. So it will go off, it will initialize a raindrop, and it will append its name to the raindrops list. So it will now become, maybe it will call it raindrop 2. Now we won't see any of this. We won't see what it adds to the list, but that's the effect that it will have. It will colour our background white. It will get to the loop, and it will say okay, for raindrop in raindrops. So raindrops now has 2 names. So raindrop will take the first item in the list, raindrop 1, and it will say okay, move it. Move it says add 7 to its y-axis, but we know that its y-axis was 2, so now it's 9. Draw it. So it'll draw it at whatever x coordinate, we don't know, that was randomly selected, at 9, and its length will be the same x, but it will have 5 added to it, and it's 1 pixel wide. But there isn't just one raindrop, there are 2, so this loop hasn't finished. So it will go back round and say okay, there's a second raindrop now. Raindrop takes the second name, raindrop 2. So raindrop 2 will now move. What's its position? Its position is randomly selected but starts at -5. add 7, so it's now 2. Draws it therefore at the random position in the x coordinate at 2, ending at 7, random selection, 1 pixel wide. So now we've got 2 raindrops. Then it sorry, it doesn't update. Yes, it does, because that's the 2 items. It updates, it goes back to the beginning, it goes through these lines of code, gets back to here, creates a new raindrop. And as we say, we can get the idea that it's adding these names on. Raindrop 3 paints the background white, gets to here and says, okay, in raindrops, well, raindrops now has 3. So raindrop will be raindrop 1 first, move, draw, go back round, raindrops now takes the second item, so raindrop now becomes raindrop 2, moves and draws it, then goes back round, raindrops now has 3 items, so raindrop becomes raindrop 3, moves it, draws it, gets to update around and recreates it. That's how the system is working. That's how it's creating these raindrops. That's the program as it's working. The class tells the system how to create a raindrop. This tells it that it needs to create a single instance, 1 raindrop. This tells us how to create raindrops. This is a single raindrop, and we're adding it to our list of raindrops. This will list all of the raindrops our system creates. The raindrops, we never destroy our raindrops, by the way. It will constantly be adding values to these raindrops. At no point does this list ever get deleted from. So you imagine how many names have been added to it and how many raindrops it needs to change and alter, remove as time goes on. And obviously the updates there. So when I run this module, I can't see it, but one of those raindrops was my very first one. Each one of these has got a name given to it. Each one of those names, I don't think I can. There you go. Didn't think I could do that, but I can, so I lied to you. Each one of these raindrops is giving its name added to this. Each one of them is being moved, then drawn, and then it goes around and creates a new raindrop. Each one of these is being moved just slightly, and the new raindrop is being created just slightly, and then another one's being created just slightly. So we're getting all these raindrops being created, each name being attached to raindrops list. Now, I don't know about you, but I can see that there are hundreds of them. It takes it no time at all for the computer to execute. Runs that once. This is the heart of the system. This is the constant, the infinite loop that runs, that creates those raindrops. Look at each of those raindrops and how quickly the computer produces it. Though all that processing is going on, though all these instructions are being followed, it's moving very quickly because the computer can follow these instructions really quickly. Now that's a lot to take on. Not going to set any questions on this because I want you to go away, explore the code and make sure you're fully aware of what that means before you go on to the second video, which will be the set of questions. Okay? Well done.